Welcome back. Today it's just going to be a review for all of Chapter 1, so it's just going to be a hodgepodge of problems that we're going to work through. Hopefully none of this is brand new information. So first example, we're going to sketch a negative 120 degree angle in standard position. So standard position, we should know, always starts with a ray going in the positive x direction. Minus 120, so minus is going to be clockwise. 120 is bigger than 90, so we're over into this quadrant, and we write that it was negative 120 degrees. Number 2, in a 30, 60, 90 triangle, the hypotenuse is 36. Find the other two sides. So draw a quick picture. 30, 60, 90. The hypotenuse is 36. Okay, I know that that's my 2a side. This is my a. This is my a squared root of 3. So if 2a equals 36, that means a itself is 18. So this short side is 18, and the long leg is 18 square root of 3. And a 45, 45, 90, again, start by drawing a picture before I even really read the rest of the question. Hypotenuse is 12. Find the other two sides. I know those other two sides are the same, and this 12 equals a times the square root of 2. So if 12 equals a square root of 2, divide both sides by square root of 2. So I've got 12 over square root of 2, which I'm going to rationalize so I can simplify my answer. That's going to equal 12 square root of 2 over 2, which is 6 square root of 2 for my a value, which is each of those other two legs. All right, 30, 60, 90, again, draw a picture. Long leg is 16. I know that's my a squared root of 3. Find the other two sides. So those are a and 2a. So basically I take the 16, oops, forgot an equal sign there, equals a squared root of 3 and solve for a. Divide both sides by square root of 3. And then I'm going to rationalize to get 16 square root of 3 over 3 equals a. That does not simplify like I was hoping it was going to, so I did a little extra work. That's okay. 16 square root of 3 over 3, and then I'm going to multiply that by 2, which if you say 16 square root of 3 over 6, that is incorrect. This is going to equal 32 square root of 3 over 3, and there's no simplifying you can do there. If you had stopped with a equals 16 over square root of 3 and then had that for your a value and 32 over square root of 3, that's also fine, since it didn't say to simplify in the directions, or it didn't say to rationalize. So complete the following identities. These all go back to sine squared theta plus I said sine, wrote cosine, and then I was going to do the reverse of that. So cosine squared theta plus sine squared theta equals 1. So that's the one that I personally remember, and then do everything based off of that. So that means cosine squared of theta is going to equal 1 minus sine squared theta. I know that secant is going to be the reverse, or the reciprocal of cosine. All right, so I could solve for cosine, take the reciprocal and square it, or I could just take this initial thing, know that I'm trying to figure out what secant is. So I'm going to divide everything by cosine squared theta, everything on all sides. Cosine squared theta divided by cosine squared theta is 1, plus sine squared theta over cosine squared theta is tangent squared theta, and then 1 over cosine squared theta is our secant squared theta. Very similar idea for figuring out cosecant squared. Just in this case, cosecant is the reciprocal of sine, so I'm going to divide everything by sine squared theta. Okay, I'm going to put this piece, the sine squared over sine squared piece, first. You could put the other piece first, it really doesn't matter. But cosine squared over sine squared theta is going to be cotangent squared theta, and that 1 over sine squared theta is our cosecant squared. So our ratio identities, tangent is the same thing as sine theta over cosine theta. which means that cotangent is cosine theta over sine theta. Our reciprocals, I've already kind of touched on it up above, are cosecant. Theta is going to be 1 over sine theta, and secant is 1 over cosine theta. Remember, I think of these as they're the reciprocals. They flipped the fraction, so they flipped that first letter. Cotangent is the reciprocal of tangent of theta. That one's way less exciting. All right, okay, that is, I mean, we've already touched on it over here, so I'm not going to write it down again. But you can write that in terms of sine and cosine as well. So in a right triangle, we're given the hypotenuse is square root of 29, and the legs are x and x minus 3. Solve for x. All right, so x squared plus x minus 3, make sure it's in parentheses, equals the square root of 29 squared. So I've got x squared plus, I'm going to FOIL, that's x squared minus 3x plus 9 equals 29. So I've got 2x squared minus 6x plus 9 equals 29. Subtract 9 from both sides. 2x squared minus 6x equals 20. At this point, you could divide everything by 2, which is what I'll do next. You could factor out. That's also fine. It gives me x squared minus 3x equals 10. So now I've got to bring this 10 over in order to finish solving, since it's not a 0 over there. So I've got x squared minus 3x minus 10 equals 0. Go ahead and factor. So I've got an x minus 5 and an x plus 2. To double check, my lasts multiply to be negative 10, and they add up to be that negative 3. So that means x equals 5 or x equals negative 2. But I need to think of the context of this problem. These are lengths. I can't have a negative length, so x has to equal 5 for this problem. Finding the distance between these points, think of one of them as x1, y1, the other one is x2, y2. So I've got the square root of negative 3 minus negative 2 squared plus 4 minus 7 squared. Negative 3 minus negative 2 is going to be negative 1 squared plus, it gives me negative 3 squared. So square root of 1 plus 9, which is the square root of 10, and that's my answer. Going back to the trig functions, complete the circular trig definitions using x, y, and r. All right, so I'm going to start with the easiest one I know, which is sine. That's y over r. I know tangent is going to be y over x, and secant, I wanted to match up with sine because they both start with s, but that doesn't work. Secant matches up with cosine, and it's the reciprocal. So I'm going to have r over x for secant of theta. Number 11, the terminal side of an angle in standard position passes through the point 4, negative 3. Find the value of all 6 trig functions. So I'm going to start by drawing a quick picture. 4, negative 3 is somewhere over here. And I'm going to drop a perpendicular down to that x-axis. So my triangle that I'm looking at got really bad all of a sudden, but that's okay, which means this side is negative 3, that side is 4, and then this side is my radius. Okay, my theta, my reference angle called theta hat goes there, because remember, when we find our angle, we're actually looking at that entire rotational angle. But now I find the 6 trig functions based off of that theta hat, which is always between the radius, or the hypotenuse, and the x-axis. So sine of theta, opposite over hypotenuse, is going to be negative 3 over r, which I should probably figure out. But I know that 3, 4, 5 is a special right triangle, so I know that that radius is going to be 5. So sine is negative 3 over 5. Cosine of theta is going to be 4 over 5. Tangent of theta is going to be negative 3 over 4. Cosecant of theta is the reciprocal of sine, so that's 5 over negative 3. I've got secant is the reciprocal of cosine, So it's going to be 5 over 4. And cotangent is the reciprocal of tangent, so that's going to be 4 over negative 3. Okay, I've got my answers. I should double check that the signs are correct. I should remember that everything is going to be positive in quadrant 1. I know cosine is supposed to be positive and sine is supposed to be negative in quadrant 4. So I've got cosine positive and sine negative, so that's a good sign. And then since they're different, tangent has to also be different, so my signs make sense. My signs for these should replicate the signs for those, so we're good to go. Number 12, if sine of theta is 12 over 13 and theta has its terminal side in quadrant 2, find the remaining 5 trig ratios. So I know quadrant 2 is over here, so I know I'm going to have some triangle this way, always make it with that x-axis, and my theta goes in that way. Technically this is our theta hat because it's our reference angle. So I'm going to redraw this triangle. I'll just say theta here, and I know 12 over 13, that's opposite over hypotenuse, so that's a 12, that's a 13. We have to figure out what this other side is. I know my special right triangles, I know my special cases, my perfect Pythagorean triples, so I know that's 5. All right, so that means cosine of theta is going to equal 5 over 13, but it should be a negative 5 over 13 because of the quadrant that I'm in. So that 5 was given to me from that Pythagorean triple, but then I have to think about where I'm actually at on the graph. I went to the left, so that should be a negative 5. My tangent of theta is going to equal 12 over negative 5. Cosecant of theta, I almost wrote cosine again. Cosecant of theta, that's the reciprocal of the one that was given to me. Secant of theta is the reciprocal of cosine, so that's 13 over negative 5, or negative 13/5. And cotangent of theta is going to be negative 5 over 12. Again, you can kind of check after you get to this point if your signs are right, thinking about the quadrant that you're in. Quadrant 2, that should be a positive sign and a negative cosine, which means that tangent should also be negative, which is what we have. All right. For this next one, find the exact value for each of the following. Some of these are easier than others. Sine, well, if you drew a quick 45, 45, 90 triangle, a squared of 2, sine would be a over a squared of 2, which is 1 over square root of 2. Cosine of 90, this is one of our quadrantal angles. Okay, I'm going to draw a quick order or a Cartesian plane over here. Think of our unit circle. I'm going to draw a real bad circle here real quick. Not as bad as I was expecting, but okay. Remember, our unit circle, we always have a radius of 1, so that's 0, 1. That's going to be negative 1, 0, 0, negative 1, and 1, 0. If our cosine is going to be x over r, cosine of 90 is of this point up here. My x value is 0. 0 over my radius, which is 1, gives me 0. Similarly, sine of 180 degrees is also a quadrantal angle. Okay, it's this one over here in the green. So sine is going to be y over r. My y value of that point is 0. The radius is 1, but 0 over 1 is 0. Sine of 30 degrees. Think of that special right triangle. This is a squared of 3, and 2a. So sine of 30 is a over 2a, which is 1/2. Okay. Cotangent of 60 degrees. I've already drawn this picture once. I can keep using it. Cotangent of 60 degrees is the reciprocal of tangent of 60 degrees. So tangent would have been a squared of 3 over a, which would be square root of 3, but I'm taking the reciprocal. So I've got 1 over the square root of 3. Secant of 270 degrees is also a quadrantal angle. So 270 degrees is, I will use red on that circle. It's that one right there. Secant is the reciprocal of cosine of 270 degrees. So cosine, it's the x over r, so I would use that 0. So 1 over 0 is not possible, so this is undefined. Okay, we were able to kind of luck out and always use the 0 on these quadrantal angles. Just remember, if you're able to find, like for this 15, if we would have been looking at cosine of 180 degrees, that would have been -1/1. Okay, you just got to remember your circular definitions of those trig functions. So use the ratio identity to find the value of cotangent. So we're given two different things, but we should remember that cotangent of theta is the same thing as cosine of theta over sine of theta. Okay, so I've got 2 over square root of 7 over 1 over square root of 7. That's the same thing as 2 over square root of 7 times square root of 7 over 1. Those two are going to cancel each other out. This is just going to equal 2 over 1. So we're going to write all the following in terms of sine and cosine only and simplify if possible. So tangent, I'm just going to go function by function. Tangent is sine of theta over cosine of theta. I'll put that in parentheses. Cosecant is 1 over sine of theta. And minus cotangent, which is going to be cosine of theta over sine of theta. All right? So right away, there's a couple of things you can look at. The thing that jumps out at you immediately, or jumps out at me immediately at least, is that these signs will cancel. So you have 1 over cosine of theta minus cosine of theta over sine of theta. All right? That's it. You're done. Okay? Because we want to get them in terms of cosine and sine, and we are simplified. So there we go. So now we want to show that each of the following is an identity by transforming the left side into the right side, showing all of the steps. Make sure that we do not change the right side at all. So I'm going to start by changing things into terms of sine and cosine. So 21, I've got sine theta times sine theta over cosine theta plus cosine of theta. That's the left side. Okay, I know what secant is. I know that that's 1 over cosine. I'm not going to write it down right now, but I know that's what I'm trying to get to. If I simplify what I've got on the left side so far, that's sine squared theta over cosine theta plus cosine of theta over 1. If I multiply this by cosine theta over cosine theta, I now have sine squared theta over cosine theta plus cosine squared theta over cosine of theta. Sine squared theta plus cosine squared theta is an identity, so that equals 1 on the top, and I've got a common denominator, so that's the same thing as 1 over cosine of theta, which equals secant of theta. So I'm done. That is my proof. For number 22, I'm going to put a little divider right there. Tangent of theta is sine of theta over cosine of theta over secant, so that's over 1 over cosine of theta. Okay, that's the same thing. That giant weird fraction is sine of theta over cosine of theta times cosine of theta over 1. Cosines will cancel each other out. This leaves us with sine of theta over 1, and we are good to go. For this one, cotangent is cosine theta over sine theta over secant, which is 1 over cosine of theta plus sine theta. So when I get this one, I have to simplify that giant fraction, just like we did the last one. Cosine of theta over sine theta times cosine of theta over 1. And we still have that plus sine theta tagging along. So I've got cosine squared theta over sine theta plus sine theta. I'm going to put that as sine theta over 1. That's identical. Now I'm going to multiply both of these by sine theta over sine theta. Okay, it's kind of a similar trick to what I got before, because I know I'm trying to get to cosecant. All right, so I'm going to have cosine squared theta over sine theta plus sine squared theta over sine theta. Those are common denominators I can add, but cosine squared theta plus sine squared theta is 1. And then the sine theta on the bottom, this is the same thing as cosecant of theta, so I'm done there. All right, this next one, less busy work, a little bit easier. Find one positive and one negative angle between negative 360 and 720 that are coterminal with 215 degrees. So I need a negative angle that is a coterminal angle. So what I would do is just take 360 minus 215. Excuse me. Hopefully that wasn't too loud if you have headphones in. So I know I know that 215 and 145 add up to 360. 215 is my positive angle, so I have an angle that is negative 145 degrees going the other direction to get to that same distance, or that same place as 215 degrees. Or I could have done 360 plus 215 to get 575 degrees for my other positive angle. I think technically a better thing to do for this one would have been 215 minus 360, since it was a positive 215. But that's just kind of how my brain works. I flip the negative and then just make sure I put the negative on at the end. So algebraically, find the intersection of these two. Make sure you show all your work. First thing I'm going to do is solve x plus y equals 5 for one of the other variables. So I solved for y. So now I've got x squared plus 5 minus x squared equals 25. All I did was substitute in this for that y. So I've got x squared plus 25 minus 5x minus 5x plus x squared equals 25. I just FOILed. It looks odd because the number came before the variable, but that's okay. So I've got 2x squared minus 10x plus 25 equals 25. Subtract 25 from both sides. You've got 2x squared minus 10x equals 0. So I've got 2x. If I factor, I've got x minus 5 equals 0. So either 2x equals 0 or x minus 5 equals 0. Okay, and then I'm going to continue my work over here. If 2x equals 0, then x equals 0. That one's pretty easy. And then if x minus 5 equals 0, then I've got x equals 5. I have to figure out what y would equal for each of those, so I come back to the original equation I started messing with and plug it in there. I can plug it in here. It's the exact same thing. They're equivalent equations. So if x equals 0, then y equals 5 minus 0. Y would equal 5. If x equals 5, y equals 5 minus 5, which is 0. So my two possible answers are 0, 5, and 5, 0. Because that was a circle being intersected twice by a line. So we didn't really cover anything new. This is just a review, but if you have things you're not 100% sure on, write them down. Write down some questions so you can go over it maybe quick before we take that test. And then these are homework problems for whatever you need help on, okay? Spend time on the things that you're not sure of. If you're like, I totally got this, I know how to solve algebraically, that's fine. You can skip those types of problems, all right? Hope everybody has a great day.